the Faraday's law. So let's take some loop here. So there's a uniform magnetic field. A current carrying sheet will generate an uniform magnetic field. Here I'll place a loop, a conducting loop. Then I'm going to spin that loop about an axis, that one. So, oh, wait. B bar, let it be. Uniform magnetic field. So let S be the area of cross-section of the loop, or side length, let it be L. I'll spin it. So we know flux linking the loop. Bs cos theta. I'll rotate with uniform angular velocity. So Bs cos omega t. This I'll differentiate. So d phi by dt is equal to minus Bs omega sine omega t. And EMF induced should be equal to Bs omega sine omega t. Look at this EMF induced, and this particular thing I'll call E naught, or in books it is also called as EM, maximum value of the induced EMF. And what is omega? Angular frequency, that one. This particular signal, when I plot it, it is called as alternating current. Very good chapter. Again, a little bit more mathematics here. Trigonometry is what you have to bring into picture. Nothing big. You have to take help of trigonometry maximum. So this will be the value of E naught. And similarly, if this loop is having a resistance R, so then what is the expression for I? Instantaneous current I is equal to, this will be E naught sine omega t by R, where I is equal to I naught sine omega t. So this particular rotating loop in a magnetic field will behave like a source of EMF. And look at this thing, it is having positive cycle. This will be positive cycle. And the next other one is negative off cycle. So like this, the current in the loop will alternate. That's why it is called as alternating signal. That one alternates, you see, positive. Next you'll get negative off cycle, again positive. Again, look at this one. So for every certain interval of time, the positive off cycle will alternate. So this is t equals 0, t by 2, t, 3t by 4, t by 4, 3t by 2, and this is 2t. So this will be the time period. So let's do one thing. What is usually the frequency of revolution, angular frequency of revolution? So as we know, omega equal to 2 pi f. This f will be 50 Hz. So in 1 second, 50 turns, 50 revolutions, the loop, the particular loop is going to make that one. So this is what individually in India, this is what followed. 50 Hz is the frequency of AC signal, we'll call it. Then can we calculate omega? 100 pi. So what's the value of omega now? Omega should be equal to 100 pi radians per second. This is the angular speed with which the loop will be rotated. So usually the standard is what we are going to pick up here. 50 Hz AC signal of 50 Hz frequency. Then let's see that. Let's go for current than EMF. So what is the expression for current I? So now how to replace this source? The resistance of the loop we show R. This source I'll replace with a symbol E naught sine omega t. So usually what is the frequency? 50 Hz. So what is the time period? Time period will be 1 by f. This will be 50. So this should be equal to 20 milliseconds. Shall we take it? Time taken to complete one revolution will be 20 milliseconds. Then for first 10 milliseconds, so let's assume that current will flow like this. And look at this current, is a constant or variable? It's a varying current. Current will increase, becomes maximum at 5 milliseconds, then start decreasing and will be again zero. Next, for this is for time. Next for t 20 milliseconds to 10 milliseconds. Same voltage, so same EMF, same loop, that one. The current will alternate. The current starts flowing in opposite direction. Any reason? Because negative current, I should change the direction of flow of current. Again, look at the current now. So earlier current what happened? T equals 0, it starts increasing. It's flowing clockwise. The magnitude of current will increase, becomes maximum I naught, then it starts decreasing. Then from 10 milliseconds to 20 milliseconds, this interval of time, the current open will change the direction of motion across the restaurant. The magnitude will increase, becomes maximum at 15 milliseconds, again start decreasing. So what is the type of what's happening to current? Current is varying with the time. You see this? Look at the nature of current. I is equal to I naught sine omega t. Look at the current. Current is magnitude is varying with the time, and also it alternates. For every 10 milliseconds, it is changing direction. Why 10 milliseconds? Because I assumed f equal to 50 hertz. So this is the nature of signal. So this you have to keep in mind. The current that flows in the reservoir is going to, for every certain interval of time, changes direction, and also the magnitude will vary continuously with the time. You can see this. If you want to write this I naught minus I naught, so then what will happen to current? Zero, it becomes maximum, then decreases. Changes direction again, increases, becomes maximum, then decreases. Like this, it will repeat. So in how much of time it will take for one cycle? 20 milliseconds. So in 1 second, how many such variations will occur? 50 variations will occur. So this is called like a alternating current signal. In short, we'll call AC. And we just show by symbol like this here. Alternating, and next we'll compare with a direct current signal. What do you mean by direct current signal? If you take their source, there's a EMF E, there's a resistor. At all the instants, current will be constant here, no? I'll call IDC. So if I go for plotting, so what about this high DC current? IDC will be a constant current. At all the time, it will be constant. It will be having fixed value. How much is E by R? What about alternating current? How the alternating current will flow? Is it justified now? Alternating and direct current. Till now, what all we discussed, all our discussion was for some direct currents here. So there's a value of, so what is value of I? I is equal to E by R. This as a function of time, I plotted. Now compare this to, this is very important. This will call direct current signal. At all the time, the current will be directed in one specific direction. Therefore, I'll call direct current signal this is. Here, it's an alternating current signal. The current will, magnitude will change and also direction. So it alternates. For every half cycle, it alternates. So therefore, it's called as alternating current signal. So you should be very specific about this one. So what is this? This is called like a direct current signal. This is called as alternating current signal. And now we know how the resistor, capacitor, inductor will respond for direct current signal. RL circuit, RC circuit. We have come across no all this. Only resistor if I connect capacitor, if I connect inductor, then RC, RLC, then RLC, all three. What happens if I connect a resistor here? What about the current? How to calculate current? How to apply Ohm's law? What is the power dissipation? Then if I connect one capacitor, how do it behave? If I connect inductor, then RL, RC, RLC. So this is the first time now what happened? We are coming across this source. So when this circuit is energized by this alternating current signal, then how to apply Ohm's law, how to apply KCL, how to apply KVL, then different types of circuits, only resistor, only inductor, only capacitor, then RL, RC, then RLC. How the circuit will be. That is what this, the whole chapter alternating current signal will be that one. So now what is the biggest problem? How you measure this current? How you measure this current? How to measure this direct current signal? So what is available? Alternating, I think ammeter is available. So what I do is I just connect one ammeter here, no? And how to get ammeter? By voltmeter, by galvanometer. I'll connect a shunt resistance in parallel. I'll just show it so they'll be easy for you. Then the same galvanometer scale will become ammeter scale. I'm able to measure this current. So I do have instrument. Okay, let's come for this. How to measure this current? What is the biggest problem we are going to face? What is the biggest problem we are going to face here? So in terms of T by 2, let me write here time, the time parameter. This is milliseconds, 10, 20, 30, and this is 40. Let me bring it to realistic, this one. Now you see that. Let me connect ammeter in the AC circuit. Any problem will arise? If I connect ammeter in AC circuit, what are the difficulties we are going to face? I'll scroll down. I'll draw that circuit here. These are the questions which we are going to ask ourselves. So for this particular alternating current signal, how to produce alternating current signal? I'll go back to EMI chapter. I'll rotate a loop in uniform magnetic field. I'll get that AC signal. This is equal to E naught sine omega t, where the current I will be a function of time. And what is this I? I'm putting once again all. Now we are going to define few terms. What is this I? This I is called as instantaneous current. Justified word. At any time t we can find out this current I know, and this is a maximum current, maximum value of current, maximum value or peak value, or if you know SHM we'll call amplitude. No, what is omega? Already I defined it. Omega is what? 2 pi f. This is nothing but the speed with which, the angular speed with which the loop is rotated. No, let me connect ammeter here. I'm going to connect ammeter. Now what ammeter will read? I think we have to be extra careful. No, exactly at you want to measure I naught. What you should do? You should come exactly for. You should be attentive. The moment at t equals 0, it will start. Switch on the circuit at t equals 0. Then at 5 milliseconds, you should open your eyes wide enough, and you should note down the reading. No. So what's happened to this pointer? How did it deflect? Let me take this emitter with a 0 at the midpoint. The emitter scale. Now, what is the difficulty we are going to face with the pointer now? At 5 milliseconds, the pointer will be somewhere. So look at the pointer. So anything will happen to pointer. The first, it will deflect in one direction. The deflection increases, becomes maximum at 5 milliseconds, let's assume. Then again, the pointer will come to 0. here at 10 milliseconds. Then again the deflection will go on to the left side, becomes maximum at 15. Again from 15 to 20 it will return back. It will be at 0. Like that, in 1 second, how many oscillations it will make it? 50 oscillations. So for a human eye, where do you see this pointer? And a human eye can, when this pointer we say flickering, so when it is oscillating, if the oscillations are say around 2 or 5, less than 9 or 8, we are able to notice. More than that, what the human eye fails to notice. So now if you look at this ammeter with 0 at the middle of the scale, so where the pointer will appear for you? The pointer will appear all the time for you at 0 only. So what we are doing, we are trying to use the device which we had earlier. Means the DC emitters, what we constructed, that only I'm connecting it. I'm trying to measure this current. How to measure that alternating current signal? See, when I say some quantity, I should know how much. No, I say DC 10 volt. An EMF of 10 volt is applied. 10 volt is magnitude. No, similarly, alternating current. How much alternating current? So shall we say that, sir, I'll express in terms of I naught. I know I naught. How to measure that I naught? Can we measure I naught? So where the pointer will be at maximum deflection at what instants of time? 5, 15, 25, 35. Can you really, do we have that much of perception? Can we say that answer at 5 milliseconds? The moment you start looking at what pen, 1 second got over, no? In that 1 second what pen, the pointer will complete 50 oscillations. So is it possible to measure I naught also? That's what my question. Can you measure I naught? No, not possible. And now instead of this 0, let it be at one end of the scale. They may ask you questions of these things practically. Actually in lab you can try it. The pointer will be at 0 only. You decrease omega, of course we can generate AC signal of low frequency. Then you can see pointer oscillating. Now let me take a scale with 0 at one end. Now what is the difficulty here? Again we'll see here. Here also the pointer cannot go on the other side, no? It should deflect. So when I switch on like an emitter with such a pointer, what is the problem I'm going to face here? This particular galvanometer will not permit to current flow in either direction, no? Only in one direction it permit current to flow. What about this galvanometer will permit the current to flow in either direction? Here during, let's say them during positive cycle deflect, during negative cycle the galvanometer will not deflect for the pointer to, the galvanometer will not permit the pointer to deflect here. So the galvanometer may get damaged. There's another thing. There's a thing. So next again, in one cycle, so only half of the cycle is permitted to complete. No? So for I naught, so somewhere in between we'll see that one here, pointer. 0 and I max, no, somewhere in between we'll see that one. So this is also not correct and the galvanometer will get damaged very easily. So if you connect DC ammeter with 0 at one end, no, so I can sure say that within 5 or 10 minutes the galvanometer will get damaged permanently. Any reason for that? Because the you're not permitting the pointer to deflect on the either side of the 0, that one. But the galvanometer is forcibly made to deflect. So there what happen, due to strain produced in the wire or in that particular galvanometer string, no, what we discussed earlier, phosphorus branch, the spring what happen will lose elasticity. After elastic effect will come. And gradually what happen, the displacement high will not be proportional to theta. And the galvanometer will get damaged. You can say that one. So what is the problem? What we are encountering? We are unable to measure the AC current. We are able to generate, but we are unable to measure how much it is. We don't have a suitable instrument. Means already the instrument what we had, if I try to use, I'm encountering a lot of problems. So therefore what I should do now? I should design an instrument which can measure this particular how much of current. Sir, I'll measure instantaneous. Can you measure instantaneous? Can you measure this at this instant? So 2 millisecond. At 2 millisecond, what is the current? I think all this not possible, no? So at 12 millisecond, I'll find out the current. The moment you blink, 1 second got over. In 1 second, how many such cycles will be repeated? 50 cycles. Huh? So I think not possible to measure instantaneous current. I cannot measure I naught. So finally it's over. So therefore what shall I do is, I will take help of the heat generated constant. We know that if a current flows through a resistor, there must be heat generated. There must be heat generated. So then I will design equipment where what happen? The deflection will be proportional to heat generated. The deflection will be proportional to heat generated. So for that purpose, I will take two circuits here. So this is the alternating current source where a current will flow. And what is I? I is equal to E by R. The same thing I'm writing in detail again. So I is equal to I naught, or instead of I naught, you can write IM, any of the symbols. So then here what I do, I'll take a direct current source, DC source. This is called like a AC source. I'll switch on this source for interval of time. For what interval of time? So let E generated in this for an interval of time, how much? 0 to t. For the same thing here, I'll switch on this source for interval of time 0 to t seconds. So I'll calculate heat generated. What amount of heat generated in the first circuit? If the same amount of heat generated in the second circuit. See, like this, here what a varying current flows. Due to varying current what and heat will be generated. I'll switch on this source for AC source for interval of time 0 to capital T. So what amount of heat is generated in the interval of time 1 cycle? If the same amount of heat is generated in the same interval of time across same resistor, then shall I say this current is equal to this one? I'll call that direct current as RMS current. I'll give some good name. I'll call that as RMS current. So if you want to write, say, some any other symbol, I dash or IDC, whatever that one, I'll call this current as RMS here. So first of all, I'll write that one for interval of time H1 equal to. So when a variable current, varying current flows, what is the expression for heat generated? I of t whole square R dt 0 to t. Here, this current I'll give name IRMS square R dt. So interval of t, the same resistor. Huh? So what I do, I'll switch on AC source for an 1 cycle. I'll make the current to flow across the resistor. I'll find out the heat generated. Then I'll replace this source. I'll bring in DC source. And I'll connect the same DC source across same resistor. I'll switch on this DC source for same interval of time. Then heat generated, let it be H2. And if I say these two heat generated are same, then definitely I can say that this current which is flowing is equivalent to this current because both effects are same. Logical thinking, nothing big. So I'll call this as IRMS. IRMS is a constant DC current which when flows across a resistor for an interval of time t produces the same amount of heat as when AC current flows across the same resistor for the same interval of time t. So like this, what the definition of IRMS is said here. So let me R get eliminated. There's a constant IRMS square integral of dt. So what is the basic definition? No, IRMS square is equal to this. What we do, IRMS, I'll write it here. So this is equal to, finally the root mean square current. That square term is very important. 0 to capital T. This is RMS value of this particular. How to calculate RMS value of that given AC signal? So what we call this as root mean square. So usually how we interpret RMS of the given AC signal. I think this is similar to already you come across at some places in KTG, current theory of gases, VRMS speed. Now different types of AC signals will come. How to calculate RMS value of that particular given signal? Okay, let's do one thing. What is the type of signal we assume? I naught sine omega t. Let's calculate for this one. The first for full sine wave. What is the RMS value of? Is a chapter which is based more on trigonometry than less on physics. So this is off cycle, no? This is positive off cycle, negative off cycle. We have to calculate RMS value of this one according to the definition. So there is a sine wave, full sine wave. It is called like a full sine wave. So now how you define this function? I is equal to I naught sine omega t. And what is the time period? This is a time period. Okay, let's write. So this is equal to I naught sine omega t whole square dt. This time period is very important. We are finding out RMS value for one full cycle because that part will get repeated again and again. This is a positive off cycle, negative off cycle. Before that, go back to the mathematics. What is the value of this one? Sine theta for full cycle, 0, no? Sine square theta, 1 by 2. Take help of the basic mathematics, what you know. I naught sine square omega t dt. And this will be integral I naught square, you take it out. So the final next, this will be RMS square I naught square by t. We can't, this will be written as 1 minus cos 2 omega t by 2 dt. This is 0 to t. I naught square by 2t. Integral of dt 0 to t. Integral of cos 2 omega. 2 omega, what we write it as? Omega is 2 pi by t, no? So this will become 4 pi capital T t dt. You know integration, you know trigonometry, take help of the mathematics, what already you know it. Integral of dt, this will be t minus integral of this will be t by 4 pi this quantity will be 0, this quantity, so will be left over with only I naught square by 2t t minus 0. After substituting lower and upper limits, so what is the value of RMS square, no? What do you mean by this? What actually, sir, what is the meaning of this? You are writing something for such a AC signal. I take a circuit. That one, so what actually we have learned. Once again, I'm repeating thing. A current what will happen? A current of I of t which will vary harmonically with the time is flowing here. Now what I do, in an interval of time 0 to capital T, what is heat is generated by sine wave signal. The same amount of heat can be generated if I send a current of magnitude I naught by root 2 for the same interval of time 0 to capital T across the same resistor. Then you can say this I naught by root 2 is equivalent of this current. So therefore the ammeter, voltmeter which I design, so how they should be, so what they should take care, the deflection should be proportional to heat generated. So therefore they are called as the hot wire instruments. When I design ammeter for AC signals, the deflection in the pointer, the deflection of the pointer should be proportional to made heat generated, not proportional to the like a theta, like what we did for DC current. Here it could be different here. So therefore, the DC ammeter or the DC voltmeter what we earlier designed is not applicable here. A little bit complicated. That's why the construction is not there. So we call them as hot wire instruments, because the deflection should be proportional to heat generated, not about not for amount of current. So like this, now different types of signals will be asked and you have to calculate the RMS value. So tell me, what is this RMS value? Once again, it's a DC current which when flows for one cycle across the resistor R, what amount of heat generated? The same amount of heat will be generated by AC signal which when flows across the same resistor for same interval of time. I think this was the definition, it was said in the books. The definition only what will happen, I'm just put everything mathematically. This is for full sine wave. What is the RMS value of full sine wave? IRMS is equal to I naught by root 2. Where do this I naught by root 2 I have to show? I naught is this one, I naught by root 2. I'll draw one blue color line. This should be the IRMS value. Keep in mind. So like this what happen? Sir, IRMS changes the action. No, IRMS is a constant current. Now your task question. Sir, in AC circuit, what current flows? Varying current or RMS current? Varying current only. This is mathematical way of expressing AC signal. Are you getting now? So now what is right? Here I'm showing I of t. Sir, is it correct if I show like this? Is it a constant current flows? No, still varying current flows. This IRMS is equivalent of this. Able to, so here afterwards now, instead of going for instantaneous current, I'll go for this RMS. How to measure that I naught? I think without I naught we can't do anything. No, I'll go back to Faraday's law. From Faraday's law, I know E naught. From there, I brought I know I naught, and I'm able to get this IRMS. Then any emitter which is there, no, it will reflect this IRMS. In fact, I naught also I don't know. I'll connect AC emitter. It will read IRMS. From IRMS, I'm going to get I naught. Or else what you should do? You should go back to the Faraday's law. You should calculate that E naught from E naught, and you should know the resistance of the circuit. Then you'll get R. Then you'll get I naught. I think there'll be more lengthy, no? Directly I'll connect AC emitter. I'll get IRMS. From IRMS, I'm able to get the I naught. Even this is also not very easy to measure. If I know I naught how to measure, then no problem, no? Got this. So no question of IRMS has brought it. Even I naught also very difficult to measure. So I'll write it very clearly. I of t, I think here, yeah, this one. I of t, I naught R cannot be measured practically. Finish sure. Okay, got this one. So these are the problem. That's why I brought the concept of IRMS. I'm making things very clear. They may test you with conceptually like this in general passage, or they can ask you anywhere. You must know the background. Rest all everything what we do is now mathematics. Different shaped curves. What is how to calculate the RMS value? This will be our discussion. Okay, I'll proceed to now for half sine wave. For full sine wave we are done now. So let's go for half sine wave. Oh. What is the half sine wave? All these data you're supposed to remember as I go for further chapters. The RMS value for different signals are needed. Remaining half of the cycle is missing. Yes, I can make it to miss. In some applications, a current of this kind will also flow. Half sine wave. Native half cycles I just show by dotted line. Now, what is the one time period? Even this also one time period. This is what which will repeat, no? Then what is this? How you define this signal? I of t, I naught sine omega t for t less than t by 2 greater than 0. You have to define, I think you go back to function chapter, different types of curves will be given. First you define that function. Once you define that function, come back to the formula, square it, integrate over interval of time, then you get the RMS value. This should be equal to 0. Then how to calculate the RMS value of this? IRMS. Let me break up this integral. 0 to t by 2. Integral is I naught sine omega t whole square dt. The value of function for interval of time t by 2 to t will be 0. So is that okay now? So the time period is not t by 2. The time period is not t by 2. Which part of graph will repeat again and again? This part will repeat, no? How the signal will be like this. I think better to this signal. Okay, now, so what is one cycle? This is one cycle. This will repeat, no? I'll this is what will repeat again and again. Check it. So 0 to t by 2 is not time period. Still the time period is 0 to t only. So you have to be a little bit alert in defining the time period, because here is what I think will go wrong. Okay, let's go for calculation. So this will be I naught square by t sine square omega 0 to t by 2. This will be 1 minus 2t. I'll bring outside here. So this will be 0 to capital T. I naught square 2t integral of dt. This will be integral of cos 0 to t by 2. No, sorry. This will be 4 pi capital T dt 0 to t by 2. Now you can denominator, okay, 0 to t by 2 shall I write, or 0 to t only? I think you go back to mathematics range. We call this time period as range. What is the range of this function? 0 to t, no? Mathematically. So bring that what all mathematics you learned, apply that here. Here we call time period. A part of graph which will repeat again and again is called as a time period. The basic definition is this one. What is the value of the function in the range 0 to t by 2? It varies harmonically. What is the value of the function in the range t by 2 to capital T is 0. Go back to mathematics, take help of this one. So now I can give different shaped graphs. I'll ask you what is RMS. This is one very popular way of testing students. Different. So this should be equal to no I naught square by 2t t by 2. This quantity t by 4 pi sine of 4 pi t capital T 0 to t by 2. What can be this whole sine 4 pi t? This will become 0. I naught square 2t t by 2. Please do make observation in exam. You are supposed to save time. Again, no need to verify. TT get cancelled, will get. So what is the value of IRMS will be I naught by 2. Now, what do you mean by I naught by 2? Means to produce same amount of heat or happen a DC current which is equal to I naught by 2. If you send it, it will produce same heat. I'm just drawing a line in every question I'm trying to draw. In books not given, because I wanted to tell very clearly that RMS is a constant current which you are making it to flow. Sir, is it really we are sending such a current? It's a hypothetical. Means if a current of this kind varying sinusoidal like half sine wave, which when it flows for an interval of time, what amount of heat is generated for the same interval? If you send a current which is equal to I naught by 2, same heat will be generated. So therefore, this is equivalent of that, the interpretation. So got the idea, no? So this is for the off sine wave. We'll put like this. Okay, next again for sine or cosine wave, answer will be same. Next, let me go for. We have discussed only sine wave, no? So let me bring cosine wave. What about RMS value for this? So this should be equal to t by 4. Oh, sorry, t by 4, t by 2, 3t by 4. This is t. So what part of graph that will repeat? So 0 to t. So this will be 5t by 4. What is one cycle? One cycle means this much here. Now what about RMS value of this function? Sine or cosine, will it be same? Because till now I just discussed only sine wave, no? So let me introduce the cosine function here. One cycle is what I'm showing it here. Now you have to be careful. First, how the current will flow? Current will flow in one positive direction for t by 4 seconds. Then it changes direction. For another t by 2 seconds, it will be in negative direction. Again it will come. Again, what when the current will flow in positive direction. So 0 to t by 4, then t by 4 to 3t by 4, opposite direction. Again 3t by 4 to t, again in opposite direction, that one. So current will alternate. This is also an AC signal only. This is one cycle. 1 cycle or 1 time period. So this part of graph is what will repeat again and again. Check it. So what is the equation for this? I is equal to, we write like this, I naught cos omega t. Let's go back to the basic formula. RMS square is equal to, now what should be the 1 cycle? 0 to t only. This is 1 second. No? There's a time period of this signal, or the range of this signal, what you can call it mathematically. Let's substitute here. This will be, numerator will be 1 by t. I naught square I'll bring outside. So this will be RMS square equal to I naught square by t cos square omega t. 1 plus integral of, this should be integral of cos omega t will be, so let's substitute all the limits, then we'll see how this function will end up. This will be t plus t by 4 pi upper limit, then lower limit will be, so this, the whole thing again, the bracket, this particular thing cos 4 pi t by 0 to t will be 0 only. So what is the equation I'm ending up? I naught square by 2t. So either it is cosine or sine wave. What is the RMS value? Will be same. RMS equal to I naught by root 2. Please do notice these are very important. So small basics, because we just carried away only by sine wave, cosine wave. Means what is the RMS value of any difference between sine and cosine? Some phase difference. Shall I call just a phase difference? Means what is the RMS value of all such signals where they're having some phase difference between them? I'll scroll to next page. There's a basic sine wave. Next, I will take cosine wave. Amplitude should be same, no? Then I'll bring another wave. Another wave will be, so there are 3 waves, what you can see. This is I naught. There's a time in seconds. So we'll give name for them. 1, 2, 3. What is I1? You can write it. I1 of t is I naught sine omega t. What about I2 of t? I naught cos omega t. And look at this. This is having some phase, no? What about I3? I3 at t equals 0, what is the value of I3? Will be 0 after some time, or if you extend back this, actually you have to extend back this one. So at t equals 0, what is the value of that one? It is negative here, no? So when you substitute t equals 0 in the function, what you should get? You should get some negative value and negative value, and it should be finite, some value that one. So this particular thing is what we'll call some phase difference. So which will come first? I think the cos, this having more phase 90, this having a phase of minus 5. This will be, so I'll do right equation. I naught sine omega t minus 5. Put t equals 0, it's having some negative phase. You can also bring another wave starting from somewhere here. We can also bring like this and all. So there's like a phase lag. Put t equals 0. So we'll get that negative value, that one. So like this, we define a signal. What is the RMS value of all this? Will be same. They're having a phase. The phase doesn't matter. Cos omega t, can you write in terms of sine omega? Plus 90 degree, plus pi by 2. Is it justified? It should be equal to plus pi by 2, that one. So the same equation, we can also write it as, put t equals 0. So I naught sine pi by 2 will be 1 plus I naught. So what is the phase of this signal? Pi by 2. What is the phase of this? Minus 5. So like that, we can define the phase of a signal. So what is the use of phase? The phase will define the instantaneous position, the instantaneous value of current at that instant of time. Go back to SHM, already we discussed the phase in waves and sound, and also in SSM chapter. So here also we'll bring it here. So like this, I can compare signal. What is the RMS value of all this? For all the signals, what is the RMS value? Will be same again. You do get very simple questions in exams. They'll give three different signals of three different phase. They'll ask you compare the RMS value. RMS value is independent of phase. Shall we put that statement? Okay, so tomorrow I'll continue. Different shaped the waveforms, we have to calculate the RMS value. That is only our idea now. It's a pure mathematics one, time being. Okay, tomorrow I'll continue from here. Thank you all of you.